Today we'll be looking at permutations. Our objectives will be to introduce permutations, to define n factorial, and to calculate a permutation using the calculator. So let's begin by introducing permutations. The first thing I need to make sure that you will remember is this. When you hear the word permutation, you need to think order or arrangement. If we talk about things being first, second, or third, things arranged like a batting order, who bats first, who bats second, who bats third, a parade arranged in an order that it's going to come down the road. Those things all will indicate to you that we're going to be looking at a permutation. Later on we'll be looking at combinations, and we don't want you to get the two confused. So let's begin with this example. If 3 students are scheduled to give a speech in class, how many different arrangements, and you've got to hear that word, arrangements, are there for the order that they speak? Obviously, there are 2 big clues in this one that tell you it's a permutation. They are the words arrangements and order. So we're looking for an order that the students are going to speak. We're going to ask who's going first, who's going second, and who's going third. So I'm going to go back to the same way we did the license plates and the telephone numbers. And I'm going to ask you, how many choices are there for who can go first? Well, there are 3 students going to speak, so there are 3 choices for who can go first. How many does that leave for who could go second? 2. And how many does that leave for who goes last? Just 1. When you multiply those together, what do you get? A total of 6. So there are 6 different arrangements for the order that the students speak. Let's go back now. Let me ask you that question again, but this time, what if there had been 7 students instead of just 3? Well, this time I would need 7 blanks, and it would be 7 times 6 times 5 times 4 times 3 times 2 times 1. And once again, you need to multiply all of those together. And if you did that, you would find that you have 5,040 arrangements for those students to speak. Well, what if that had been 10 students? 10 blanks, so 10, 9. So then I would need to multiply those together. And when I do, I get 3,628,800. Now, you can only imagine how complicated this is going to get if I ask you for 30 students or 50 students. So let me show you the shorthand way for writing that. It's what we call n factorial. That n with the exclamation point doesn't really mean n, it simply means n factorial. If 3 students are scheduled to give a speech in class, how many different arrangements are there for the order that they speak? You already know that this is 3 times 2 times 1. Well, here's what factorial means. When you have numbers that are multiplied together and they start and work their way all the way down to 1 and nothing is skipped, that's when you have 3 factorial. It's still equal to 6 just like it was before, but I want you to see this notation right here. If there had been 7 students, remember how we did the numbers a minute ago? 7. Well, that's also equal to 7 factorial. And then we had the example of 10, and that one is equal to 10 factorial. Now that's a nice shorthand way of writing that big long string of numbers. So if I ask you about 50 students now, you'd simply write 50 factorial instead of listing that whole group of students. And you already know what that 10 factorial is equal to. We did that a minute ago. What's nice about this now is the fact that we can calculate n factorial using your calculator. So if we want to calculate 3 factorial on the calculator, here are the steps you would use. You enter the 3, you go to Math, move to the right 3 times, and that will highlight the probability section. You then enter a 4, and you should see the exclamation point there, so that's what you're looking for, and then hit Enter. And that's exactly what you should see on your screen. When you enter, it will come back and give you 3 factorial. Let's go on and do 7 factorial on your calculator while we're there. You enter the 7 first, then get the factorial by going to Math, move over to the right to Probability, choose 4 for factorial, and hit Enter. You should have your 5,040 right there, and if you went on and did 10 factorial, you would see that you get the 3,628,800. Now what I want to do is I want to talk to you a little bit more about permutations by using an example dealing with batting order. A softball team has 10 players. How many batting orders are possible? What that's asking you now is how many different ways are there to arrange the orders that the batters are going to hit. Who's going to bat first, who's going to bat second, who's going to bat third. And so as soon as you hear that word orders or arrangement, you know that you're talking about a permutation. So this time I have 10 players. How many choices are there for who bats first? Hopefully now you're thinking that this is very similar to what we did a minute ago, and you're exactly right. That's 10 factorial, and it's equal to 3,628,800. I want to change the problem just slightly now and give it a new twist. Now let there be 13 players on the team. How many batting orders are possible if only 10 players bat? It's an entirely different problem. I know it sounds very similar, but it's very different. Let's talk about it first of all. There will be 10 players batting, but let me ask you, how many choices are there for who bats first? 13. 12. But we only are going to use 10 batters. So when we get to 4, we have to stop. Well, that's no longer 13 factorial, is it? You can still calculate it, and it turns out to be this really big number right here, but it's not 13 factorial. It does turn out, though, there's a way we can calculate it. So let's look at this problem again. And I want to show you another way to do both of these. The softball team has 10 players. How many batting orders are possible? This time we're going to use permutations to calculate it. This would be the permutation of 10 things taken 10 at a time. There are 10 players on the team, and all 10 of them are going to bat. This symbol says we're dealing with a permutation. To do this on the calculator, you have to enter this number first, so we'll enter the 1 and the 0. Then we have to tell it we're doing a permutation. I know that seems a little out of order, but that's how it works on your calculator. To do that, you'll go to Math, move to the right to Probability again, and this time you'll enter a 2 on your calculator because that's the NPR. That's the one for permutation. And then you need to enter the last number, the last 10. I failed to write it on the screen, but we'll put it in right there. Once you do that, here's what you should see on your screen, and when you hit enter, you get the 3,628,800 that you know is the correct answer. We've already done this. It's just another way of doing this one. But here's what's really nice about permutations. That last problem that we had to multiply all the numbers together because we didn't have another way to do it, factorial didn't work. Now you can do that one using permutations. It would be the permutation of how many things do I have total, 13, and how many of them am I going to use, 10. So a permutation of 13 things taken 10 at a time. We would enter the 13 first, Math, move to the right to Probability, choose 2 for NPR, and then enter that last number, and I left it off again, it's a 10. So it would be 13 things, NPR, 10, and then it gives you your answer right here. Let's go ahead now and look at another application. This time we have students giving a speech. In a class of 30 students, how many arrangements are there for 4 students to give a speech? Right here's your key word again, arrangements. We're talking about order. If I were only asking you how could I select 4 students to give a speech, not caring what order they go in, we would not be talking a permutation. But in this case, we're talking arrangement, meaning there's a significance to their order. Once again, it will be a permutation of how many things taken how many at a time. Well, in this case, it's 30 students taken 4 at a time. 30, permutation, 4, and I get 657,720. By the way, I do want to make sure that you still understand. Some of you may have said, I would have thought I could have done my fill in the blanks on that. I would have said 30 students for the first choice, then 29, 28, and 27. And I want you to see that it turns out that that is exactly the same answer. And for 4 students, this may not be a big deal. If I changed this to 15, you might not want to do it that way. This way would still be straightforward. That's all I have for you today on permutations. Have a great rest of the day, and I'll see you again soon. Bye-bye.